different things today. Again, make sure that your packets are up there. If they're not up there, I will not accept them. Finding missing parts of right triangles. That's the main theme of today's lesson. Finding missing parts in right triangles. Yeah, I put that last time. I put that last time. Put it up there. Still got it. So we're going to be finding missing parts. The first thing that we're going to cover, Pythagorean theorem. If you know two sides in a right triangle and you're looking for the third side, then you can just use Pythagorean theorem, and most of you probably have used Pythagorean theorem at some point in the past. Got to make sure with Pythagorean theorem, the problem that I see most of you having all the time is, and I'm sure when you did it back in 5th or 6th grade or whenever it was, what the teacher always did was they gave you a triangle and they told you this side was 3 and this side was 4, and you were looking for that side. And you set up Pythagorean theorem and you found the missing side. The problem is, probably 90% of the time you were always looking for the what? The hypotenuse. Is that the way it's always got to be? No. So if I give you another triangle, and I tell you this side is 4 and this side's 5, and I want you to find that side, then how would we set up Pythagorean theorem?
4 squared plus b squared equals y squared.
And you got to make sure that you're doing that correctly every time, setting it up correctly. That's the main mistake I see with Pythagorean theorem, is that most people, they want to put A and B in all the time, even when you know C. How do you know which one has to go in C right here?
It's always the hypotenuse.
It's always the hypotenuse. It's always across from the right angle. And you might want to write that in also. The hypotenuse always has to be what? It's always always has to be the longest, the biggest. The hypotenuse is always the longest side. Hopefully most of you know how to do Pythagorean theorem. We won't spend a whole lot of time on that because I think you've done it in the past and you can handle it. These are called Pythagorean triples. What a Pythagorean triple is 3 numbers that when it's stuck into Pythagorean theorem, it works. So if I stick in 3, 4, and 5 into Pythagorean theorem, the 5 has to be which one? The hypotenuse, the C. So 3 squared plus 4 squared should equal 5 squared. Well, 3 squared is 9, 4 squared is 16, 5 squared is 25, 9 plus 16 is 25. So that means those would form a right triangle. These Pythagorean triples, very, very important because they make things easier on you if you know them. So I highly suggest you write down the stuff that we're writing right now so that you can try to have them memorized. And the ones that I have up here, there's a whole bunch of Pythagorean triples, all right? These aren't the only ones. These are just some basic ones. Does that make sense?
So how will this make it easier for us?
Because you're going to see a triangle and it's going to look like this.
So it'll like save you time, so you know the answer. Okay.
What can you tell me X is right there? 5. If I gave you another triangle, what's X there? 24. You don't even have to do Pythagorean theorem. You don't even have to set any of the stuff up. Now, along with these aren't the only Pythagorean triples. There's all kinds of them, and there's others that would go on down. I usually say that like the 3, 4, 5, and the 5, 12, 13, these are the heads of the families, but there's other ones that could branch off of that. So if I gave you a triangle, look like this. Anybody have a guess as to how long that hypotenuse would be? 50. How'd you get that?
3, 4, 5 to the side of 0.
All right, and we didn't just add a 0. What's that? What's the operation we're doing in math? Multiplying by 10. So other ones that fit into that 3, 4, 5 would be something like 6, 8, and what? 10. What I do to the 3, 4, 5 to get 6, 8, 10? Multiplied everything by 2. So that's another Pythagorean triple. Give me another one. Besides 30, 40, and 50 that we just did. Say it again. 12, 16, 20, so on, so on, so on. So if you see a triangle, and you can remember this, you see this side's 12 and this side's 20, what's that third side have to be? 16. And I'll guarantee you on stuff like the OGT test, they use these triangles over and over and over and over and over again. Instead of trying to come up with some triangle that comes out all crazy, they want stuff to come out even, then they use these Pythagorean triples over and over and over and over again. Give me another one that would go along with the 5, 12, 13 one here. And are there other ones on out through there?
I got
Yeah.
what I got good. 50, 120, 130.
50, 120, and 130 would work. All right, so there's all kinds of them. And if you can pick up on those, then it makes everything a little easier. You don't have to do so much work.
Can I get my prune?
Were you going to ask me after you ate it, or?
No, I just have to smell it. It's just a little tiny thing. See, it's a dried up raisin, it looks like. I don't even know what these are. But they're good.
Eat it real quick. All right, write this down. Special right triangles. 2 special right triangles. You don't really have to skip a whole lot of space in between each one. I'm going to write just one thing with each thing for this, and then this is probably the hardest thing that we're going to cover today. I went over this with my other class, and I could tell that they were lost. So I'm hoping you guys aren't that way.
Did you get the cold illness?
What?
The cold? The Ebola? Ebola. I've had it for almost 2 weeks now.
I'm feeling better now. There's been like, I think you got illnesses going around. It's the cold. It's terrible.
It's the Ebola.
It lasts for like a week.
I'm gonna jinx myself.
All right, a 45, 45, 90 triangle. 45, 45, 90 triangle. Are we dealing with the sides of the triangle like we were with Pythagorean triples? No, what do you think we're dealing with?
Angles.
The angles. In a 45, 45, 90 triangle. Make sure I'm on pin here. Another name for this?
Right triangle.
That's close.
Isosceles.
It's an isosceles right
Yes.
triangle.
I knew it.
The reason it's an isosceles right triangle.
Because 2 sides are the same measurement. Oh, that makes sense.
The two legs are the same, and you have your right angle in there. 30, 60, 90 triangle, you really don't have to draw this.
That's the right triangle. Scalene.
That's going to be like this, and you're correct, it would be scalene. It's going to have a 30-degree angle, a 60-degree angle, and a 90-degree angle. Now, what's special about these is they, no matter what, we've been dealing with setting up these proportions and matching everything up. And somebody figured out a long time ago, hey, if every triangle that we match up is a 45, 45, 90, then it has certain properties. If it's a 30, 60, 90, then they all have certain properties. And we really don't have to match them up to some other triangle that's the same. We just say, we know that this 30, 60, 90 triangle always has these properties. This 45, 45, 90 triangle always has these properties. On the first one, write this down. This is the key to all this. On this L right here, I put a capital L because I'm not very good with the computer. You'll never see me make a capital L. I'll usually write a cursive L. The book, if you look in the book, they might use, I don't remember what this book uses. A lot of books will just use an X in place of that L. I don't like to use X's because we use X as a variable all the time and it just gets confusing. Why do you think I chose to use L? Because that was a leg. It's L times the square root of 2. So if you have a triangle and you know it's a isosceles right triangle or a 45, 45, 90 triangle, what I want you to do, very first thing, go in here, draw these little arrows across from the angles, across from both 45-degree angles, label those sides L. Across from the right angle, label that side L times the square root of 2. Every single time you see one of those triangles, you go in and you label the triangle that way. Now, what this is going to help us with, if I give you a triangle, tell you that that's a 45-degree angle, I tell you that this side down here is 7. What can you tell me about that side over there? 7. What can you tell me about the side across from the right angle? This is the one that confuses everybody. It's 7 times square root of 2. Don't grab your calculator, just leave it that way. That's a good form. 7 times radical 2. Just leave it there. Alright? So if I gave you another one, told you this side was 8. That's a 45-degree angle. This side over here, the other leg's 8. What's this side? 8 times the square root of 2. Just leave it that way. Now, if for some reason you're doing a ACT or OGT or some kind of test, and they give your answer as a decimal, then you have to take your calculator and you take 8 times the square root of 2 on your calculator and figure out what it is as a decimal. But otherwise, that's the way you're going to leave it. What if I gave you this triangle? So how long is this side?
2.10. I don't know.
How'd you get 10?
Oh, yeah. That makes sense.
And how long is this side?
10. I was thinking that.
Alright. So, if you know that, then it should be fairly easy. Now, there's going to come times when they're going to give you this and tell you it's a 45, 45, 90 triangle. and they're gonna tell you something like this side over here is 12. Well, then that's not so easy, and that takes a whole lot more work, and we'll get into that more later on, alright? I don't wanna go into all that right now. The other thing that I want you to write down with this. Thing that goes along with 45, 45, 90 triangles. If you have a square, so if you take a square and you draw in, anybody remember what this is called? A diagonal, right? Thought I heard it. If you draw a diagonal in a square, guess what's formed? 2, 45, 45, 90 triangles. So if I told you you had a square and each side was 15, could you tell me how long the diagonal is?
15 square root of 2.
15 times the square root of 2. If I gave you another square and told you that a side was 4, how long was that diagonal?
4 times the square root of 2.
4 times the square root of 2. Alright, so you can make things easier. That's what a lot of this stuff that we're covering today is supposed to make some of the things a little easier. The 30, 60, 90 triangle. Write this down. I'm going to redraw. Can everybody read that, or should I redraw it? You can see it?
Do we have any notes after this one? Oh, hey, Mr. Russell. You know that quiz? After this one? You know that quiz that I was absent for? I just wrote my answers on the sheet. Do you want me to put it on where we put our other papers in?
Wait on my big chair up there.
Think? Okay.
Alright, same idea with the 30, 60, 90 triangle. First thing I want you to do every single time you see a 30, 60, 90 triangle, go through and label it. I'll move this here in 1 second. So if you have a 30, 60, 90 triangle, side across from the 30-degree angle is always labeled L. Side across from the 60-degree angle is always labeled L times the square root of 3 this time, not the square root of 2 like in the 45, 45, 90, but the square root of 3. And the side across from the right angle is always labeled 2 times L. So very first thing, as soon as you know you have a 30, 60, 90 triangle, go through and label it that way. Then you can start picking out what you know. That confused you, Sophie?
Yeah, I just don't know.
So on where it says longer leg opposite the 60 equals L, what's it on? Times what?
Oh, I died.
Oh, it didn't. It's supposed to have square root of 3 in there. It disappeared on me somewhere. Where'd it go?
It's so weird. Like,
I was just like confusing what it was.
It moves around, so it's somewhere. You watch. It'll probably show up on the next slide or something.
it's weird to think like when we first started doing multiplication, it was just like an X, and then it changed to a star, and then it changed to a dot.
Yeah.
Like that's seriously how like it was.
Yeah.
Like the asterisk star.
So make sure, because I didn't realize that. I thought it had it on there. make sure you put L times the square root of 3 there. So if I gave you a triangle, and you knew it was a 30, 60, 90 triangle, and I told you this side over here was 5, could you tell me the other sides?
5 times 2.
Which side is that, this one or this one?
The hypotenuse.
The hypotenuse is 5 times 2, which is how much?
10.
10?
And then 5 square root of 3.
5 times the square root of 3.
Do you want us to just leave it like that?
Leave it like that. Unless for some reason, you know, if the answers are given in decimal form, then you grab your calculator and do the multiplication, but otherwise just leave it that way. What if I gave you this triangle, told you it was a 30, 60, 90 triangle, and I told you this side was 20?
Then you would divide that by 2 for your short leg, which would be across from the 30.
Okay,
10.
so that side over there would be
The
10.
next one would be 10 times the square root of 3.
Does that make any sense? Sophie, that makes sense now? A little more? Don't lie to me if it...
Well, I mean, it makes more than with the numbers in there than seeing it like with just the letters.
So every single time, if you see one of these, first thing you should do, label it. That side should be labeled L, that side L radical 3, that side 2L, to help you out if you're getting confused. That's what's going to help you. I don't want to say you have to, because maybe that confuses you more, but I would think that if you're getting confused at all, then yeah, I would want you to go through and label it, because I think that's going to help you. And then once you know, so like on this one, we knew that this side over here was the 2L, well then 2L had to equal 20, right? Divide by 2, and L equaled 10, and then wherever you see an L, you stick in 10. So those are two special kind of triangles, 45, 45, 90, 30, 60, 90. Right.
Oh.
Sine, cosine, tangent. I think I'm going to skip this slide.
No, you really shouldn't. You're
Can't
gonna say after
use-
school today, and you're gonna teach it to me again, because I still don't get it.
Can use to find missing. Go ahead and write this.
Sleep. Is that okay if I try to stay after today? I'll call it.
All right, trig ratios. Just like with the 30, 60, 90, the 45, 45, 90, what somebody figured out a long time ago was, hey, if we take a right triangle, and that right triangle has some certain angle in it, maybe it's got a 32-degree angle in it, and a right angle. Well, every other triangle in the world that has a 32-degree angle and a right angle is going to be similar to that one. And so what happens there is all these sides, the sides that match up to each other, are proportional to each other. And instead of going through and doing this separately over and over and over again, and setting up all these proportions like we've been doing all the time, and have to have two triangles every time, what they figured out is, hey, instead of doing that, why don't we just go down through and figure out what those ratios are and make a chart for it. And that's what this chart is. All right? Now, probably most of you don't care to use this chart because it looks like a lot of numbers and a lot of silly stuff. So what somebody did right after that was on your calculator, they programmed in that chart. So if you're looking at a 32-degree angle and you want to know how this side right here and this triangle compares to this side over here, all you got to do is hit sine, the S-I-N button, 32, hit enter, and it tells you. All right? So on your calculators, we're going to do a bunch of stuff on them, so make sure you have them out there. First thing, and this especially on the park test coming up, something that we figured out. If you got a TI 83 or 84, this mode button, you go in there, you have a TI 83 or 84, you hit the mode button, go down to the third one, and it says radians, then degrees. It's always got to be on degrees. And on the park test, when you guys are doing this, their calculator is like this one, and it always jumps back to radians. So you have to go in that mode. Everybody listening to this? You have to go in there and change it every single time you use it to degrees. So the way you do that is you go down till you get to that radians degrees, you go over to degree and hit enter. All right?
We have like an actual calculator that we can hold our hands on it, so that's why we have to go through it every time.
So
How do you change it? You go to.
it's not on yours. It's on the TI 83s.
I can see mine on here.
Well, we need TI 83.
That's all they'll let you use because it's right there on
Well, we need it for this. So, what we're doing right now.
the. No, this will work.
Degree enter.
So you hit mode, go in there and make sure it's in degrees all the time. Because the one on the park test goes back to that every single time. I don't know why.
You just really don't look at it, like, no, the third one down.
All right, write this down. SOHCAHTOA. All right, what this stands for? S here stands for sine. The C stands for cosine. The T stands for tangent. Those are your three trig ratios. The sine is the ratio of, if we have a right triangle, if we pick this angle right here, we'll call that angle A. Very first thing, if you know that you're dealing with the trig ratios, sine, cosine, tangent, and you know that you're dealing with angle A, first thing you want to do is come in here and label it, these three. Opposite leg, side across from the right angle is always the hypotenuse. And then the side that's hooked to the angle that you're dealing with is called the adjacent leg. So the sine is always the opposite leg over, what's H stand for? Hypotenuse. That's the ratio. And all we've been doing here lately is setting up proportions. Well, now all you're really doing is setting up that one proportion, or that one ratio, sorry. What do you think cosine is then? Adjacent leg. Over hypotenuse. Then what do you think the TOA means? Opposite leg. Over adjacent leg.
Okay, so when you're like writing the answer, when it says like the COS and like 35 or something, is 35 the angle they give you, and then the fraction, or sorry, fraction, I guess, is the whatever one.
All right. And we're going to do a few of them. So if you look on that chart that I just passed out, that chart gives you how all those would match up for every different angle. 22-degree angle, a 10-degree angle, so on and so on.
Will we get used on the test? Or the sheet, yeah. Like, will we get the sheet?
No, because it's all programmed into the calculator.
Yeah. So, how's our homework? Alright, cool. Wait, that's kind of nice though. Even though if you typed it.
All right, this is just another way to write it. This is how it looks when you're setting up an equation. Sine of some angle equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Tangent equals opposite leg over adjacent leg. If you wanted to write that down, it might be easier for you to look at it that way.
Hey, I'm not gonna complain about this just because at least I got them done. But you could give me us huge packets, so I feel like for the test we will be like on it. Like we just did this, we did a whole packet on it. We'll have it down.
Some of these, the reason this packet's so long is because a lot of them are just real easy.
Yeah, but and then like some teachers haven't been doing any work with us, so like
yeah.
we'll do awesome on like the math. We take geometry. We'll do awesome on geometry, and they're like, man, those kids are smart. And then we'll get to the other ones.
I hope that's the way it works out.
Yeah, we don't even know.
She's not even worried.
We're gonna have to use like figurative
This
language
Stevens
to
is
be like,
worried. She
well,
knows
I know what a
He just cares about Shakespeare and
It's a little easier not to be worried about English because all of you have been speaking English your whole life. But
Yeah,
Well,
that's what
yeah,
I was
but we have
thinking.
students-
There has to be a set
We
answer.
have like figurative language and stuff.
if you
like-
can write, you can probably pass an English
Yeah.
test, right?
But still,
Oh,
yeah,
we have to write an essay.
Oh, I have a
yeah,
question.
between like nerves and just like looking at it, it's just like.
Which
Why
on the
not
bright side,
understand
all we
stuff?
need is 1 point. Oh, wait, that's all we need.
Like,
Yeah,
I don't
we need
understand
1
why they
point for
ask
this
stupid
class and for,
questions.
They do.
or take it out of science completely.
Yeah.
Yeah.
And for this class, you only have to get 1 point, because you already have 3 for algebra.
For our homework.
All right, with this, because I want to move on. Watch. If you're dealing with a right triangle, let's say we want to deal with angle B. That's the angle maybe they tell us what angle B is, and that's the angle we want to deal with. Then what you need to do, if you know you're using sine, cosine, or tangent, if you're using the trig ratios, I'm using the wrong marker. What you need to do is come in here and label it. That side is going to be labeled the opposite leg, and you can just put opposite. That side's going to be the hypotenuse. Then the side that's hooked to the angle you're dealing with is the adjacent. So you got to label all 3 of those so that you can set up each of these ratios every time. Know which angle you're dealing with. Next time you might want to deal with angle A. Right? This time if we're dealing with angle B, then this is the way it's labeled. What would change if you were dealing with angle A? Would the hypotenuse move?
No.
All it's going to change is
The adjacent and the opposite.
those 2 would switch for the other angle. All right? And And then all you're going to do is, if they want you to find the cosine of angle B, well, the cosine of angle B is what over what? SOHCAHTOA.
Adjacent over hypotenuse.
Adjacent over hypotenuse. And you would put in those two. Now, if you go, if you look at that worksheet, on the front page, just to try to run through a bunch of these together. If you look at number one says the sine of a 12-degree angle. You can either look at that chart, or an easier way is just to grab your calculator, and on your calculator, you punch in sine 12, close the parenthesis, and what's it tell you?
2.0792079.
And we usually go out 4 places, and that's about where we cut it off.
That's it. Okay, well, I guess
So that tells us then what we're saying with that is in every right triangle that has a 12-degree angle, the opposite side compared to the hypotenuse will always be 0.2079.
What if you have one with like?
Now, if yours is messing up and you got one of these TI-30s, the reason, just like I was saying, it always has to be in degrees on the TI-84s, it should say degree here somewhere. Now try. You see up here where it says DEG? It's always got to be there. If it's not, then you're in the wrong setup.
Okay.
Wait, can I take your school today? I just want to work on this stuff.
What if one
This
of
is
your
like an idea.
What if one of your answers happened to be like 1 point blah blah blah? Would you go like for a decimal? Always for a decimal?
Now, the other thing I want to say here, listen closely to this. Sine and cosine always should be less than 1. So if you have something like 0.2079, that's fine. If you come up with a sine or cosine that's something like 1.5, something's wrong. Tangent can be anything. Tangent could be 50.8. But sine or cosine always has to be a 0 out in front of that decimal. Can't be anything else. Jump down to number 13. Watch how you do this problem. Cosine of x equals radical 3 over 2. You take your calculator. This time we're actually looking for that x there, which is the angle. So you've got to do it backwards. What you do on your calculator is you hit second cosine, and notice what's it pull up? Cosine -1, that means the inverse of the cosine. So what it's telling you is on this chart that I gave you, it's telling the calculator to use the chart backwards. It's saying start over here in the columns and figure out, go back to the angle, what the angle is. Does that make sense? And then you punch in second square root 3, then you got to close that parenthesis, divided by 2, close the other parenthesis, and then hit equals, and what's it tell you? So what's the measure of the angle? 30 degrees. Yeah. Yeah, just stop down in the office and send you over there.
Mine says syntax error.
Because you didn't close the parentheses there.
Very close. How would you do 14?
We'll do it here in a second. So hit second cosine, second square root. parenthesis. That's with just the 3 divided by 2, close the other parenthesis. Because see, it doesn't understand that you had, like, you had 3 parts of a parentheses, that doesn't make 2 whole parentheses.
Is it 30 again?
I don't know, what was it?
I just got 30 again.
Which one is this, number 14?
14? Oh, did you do square root?
14, so 14 you hit second,
Oh, yeah, that's right, I did.
sign, 1 divided by 2. What's it come out to be?
45? 30? Oh,
It
so
does?
you do square root even if there's not
No,
one?
the square root, where'd you get square root at?
For
We
14?
don't do square root.
There's no square root. I got 45 on that though.
I got
Sarah got
45.
30 while using square root. I got 45 without using square root.
Remember too,
I
yeah.
got 30 not using the square root.
Do you not close your parentheses then?
You didn't, you closed your parentheses in the wrong spot.
So you don't close it.
You close it after you do the 1 divided by 2.
That's weird. Sarah got 30 while using the
Oh.
while using the.
Because you want 1/2, right? You guys are doing 1, you're taking the square root, then dividing the whole answer by 2 is what it's telling it to do. Look at problem 22 real quick.
I got 45 on 16.
Problem 22, they give us this. Right angles there, 12, 9, 15. This is angle Z. We want to know the cosine of angle Z. And all you have to do here is label it. This is the angle we're dealing with. That's the opposite. That's the hypotenuse. This is the adjacent. Cosine deals with which 2 parts?
Opposite hypotenuse.
The leg.
Cosine. Subca toa. Ca.
Opposite and hypotenuse, so it'd be 9 that.
Opposite. No, not opposite in hypotenuse.
Adjacent.
Adjacent hypotenuse.
So
Oh, yeah,
12.
that's right.
12 over 15, and that's all you have to write is 12 over 15.
Hey, I'm done. That sounds good. Sokotoa. I'll like say that to myself before I go to bed tonight.
I know, I wanna work on it.
Right on the worksheet, I'm going to do a few of the problems. We'll just try to go through, I think I already did number 1 on this video, so we'll do number 2. Do a couple from each section real quick. Number 2, cosine 14 degrees. All you do for cosine of 14 degrees is on your calculator, you just hit COS button, hit 1, 4, and you probably don't have to. I know most of the newer calculators pull up a parenthesis right here. You can close the parenthesis. You don't really have to when you're just doing this step, but so if you do that, calculator. You should come up with 0.970, and then it goes 2, but then it's got a 9 after that, so we'll say 3. Go out 4 decimal places. Number 3. Sine 48 degrees. So on your calculator, you hit sine 48, close the parenthesis, hit equals, gives you 0.7431. And again, for these, if you're on this calculator, if you look right here on it, or somewhere on different TI-30s are a little different, but on mine, it's right there. It says DEG. And you want it to say that because you want it to be in degrees. If it says RAD or DRG, then it's not right. It's not set in the right mode. Or it's not set in the right thing, so you need to change it, but it needs to say DEG on it. If you have the TI-83 or 84, you got to make sure, especially on the park test, you got to go to that mode button, and on that mode button it'll pull up a bunch of stuff, and the third line down will say radians, then it'll say degrees, and every single time on the park test, if you're dealing with any of these, you got to make sure that you use these buttons to go over to the degrees and then hit enter so that it's in degrees all the time. So if I move this out of the way, what I would want to do is I hit the mode button, then it'll pull up the screen and it'll say, like the third line down here, will say radians and degrees. And I want to use this key to switch it from radians to degrees. It'll highlight the degrees, then you hit the enter button, and then you just hit clear, and it'll go back to the regular screen, but then it'll be in degrees. So you always got to make sure that you're in that. Every single time you got to go back and do that on the park test, on the calculator that they have on the park test. Let's do number 4. Sine of 38 degrees. And again, we just punch that in. Hit sine 38. And we got 0.615, and we'll round it up to 7. Let's jump down to number 9, because number 9 is a tangent. It says tangent of 51 degrees. Or we just hit tangent 5,1, close the parenthesis, hit enter, and it gives us 1.234, and we'll round that up to 9. Again, we go out 4 places every time. And something else you should notice every single time, again, in case I didn't mention this in class, anytime it's cosine or sine, it's always less than 1. So it's always got to be 0 point something, something, something. If it's cosine or sine. If you get anything that's bigger than 1 for cosine or sine, then it's wrong. If it's tangent, tangent can be anything. It can be bigger than 1, but cosine and sine can't be. All right, jumping down to the next set. Let's jump to 15. It says the tangent of x, so the tangent of our angle that we're looking for, equals 1. So what you got to do on your calculator is you hit the second button, because you're not finding the tangent this time. You already know what the tangent is. The tangent is 1, but you're trying to find the angle. So you hit the second button, then you hit tangent, and it should pop up on your screen to look like this. And that means you're finding the inverse of the tangent. So it's telling the calculator to use that chart that I passed out in class to use it backwards, to start with the tangent and go backwards to the angle, instead of starting with the angle and finding the tangent. And then you just put in whatever they have there, which in this case is 1, so we put in 1, close a parenthesis, and it tells you that your angle equals 45 degrees. So number 16, they tell us sine of x equals 0.6258. So on our calculator, we hit second sine, so you hit second sine, and again it pulls up that sine -1. Then you just punch in the numbers, 0.6258, and close the parenthesis. Then you hit equals, and it's going to tell you what your angle is. And it comes up to 38.74 something. Normally, if we're dealing with angles, we'll just round it off to the nearest degree. So we'd say about 39 degrees is what the angle is that time. Let's jump to number 17. Cosine of x equals 0.6258. So we hit second cosine 0.6258. Hopefully you realize that we just seen that number up here in the problem right before it. Hit equals, and it comes out 51.259. So we'll round it off to about 51 degrees. What should be true about these two? This was the cosine for an angle that's 51 degrees. This was the sine for an angle that was 39. Well, if you look at those two, they're complementary angles. They add up to 90. So if you have a right triangle, what this is saying, if you have a right triangle here, and this angle is 39 degrees, this angle is 51, the cosine of this angle is going to be the same number as the sine of that angle, because all the switches are the opposite and adjacent legs switch back and forth there. All right, if you hop down to the next one, problem 22. They give us a triangle that looks like this. You got 12, 9. It's a right angle. This is 15. And they want to know what the cosine of z is. The cosine of angle z. Let's get rid of that. Cosine of angle z. And all you really have to do on this is write your ratio. When we take angle z, we label this triangle according to angle z. That's the opposite leg. That's your hypotenuse. This is your adjacent leg. And for cosine, remember in your TOA, that's the cosine. Well, it's adjacent over hypotenuse. Well, the adjacent leg this time is 12, and the hypotenuse is 15. And you can just leave your answer that way. They give us this. This is 32. That's a right angle. 24, 40. This time they want us to find the sine of angle A. Angle A is this angle, so we label the triangle according to that angle. That's your opposite. Let's get rid of that hypotenuse up there. That's your opposite leg. That's your hypotenuse. This one over here would be your adjacent leg. Well, the sine is the so part. So sine is opposite over hypotenuse. Opposite over hypotenuse. The opposite leg this time is 32. The hypotenuse is 40. Now, if we wanted, they didn't ask us to do anything else other than find the sine of that, but we could figure out what angle A is by doing what we were doing on that last one, taking our calculator and hitting second sine 32 divided by 40, close the parenthesis, and it would tell us that angle A is about 53 degrees. They didn't want us to do that on this section, they just wanted us to find that ratio, so that's all we put down. (24) give us this triangle. This is 12, 37, 35. They want to know what the tangent of angle C is. Well, angle C is here. That's going to be your opposite leg. 37 is your hypotenuse. This is your adjacent leg. Tangent, that's the TOA part of our SOHCAHTOA. So it's opposite over adjacent. Opposite this time is 12. Adjacent is 35. That could be your answer. And again, you could reduce those down, sort of unnecessary, because you'd probably just be punching into a calculator anyway. If you flip over to the back, problem 28. Here you're just using Pythagorean's theorem to find the missing side. This one's pretty easy because you're looking for the hypotenuse. So this is a leg. Or your hypotenuse is here. Remember, that's always got to be your C. Got a leg here. So it's going to be 4 squared plus 8 squared equals C squared. 4 squared, 16, 8 squared is 64. C squared, 16 plus 64 is 80. C squared. To get rid of the C squared, you take the square root of both sides. Grab your calculator. And they said round your answer to the nearest tenth. So that means you want to go out 1 decimal place when you round off your answer. So you hit second square root 80, enter. You get 8.94, so we'll say that C is about 8.9. Jump down to, let's find one where we're looking for a leg. Well, we'll just go right to 29. If you go to 29, give us this triangle. This is our right angle. It tells us the hypotenuse this time is 7.4. That leg is X, that leg's 3.6. So it's going to be 3.6 squared plus X squared equals 7.4 squared. Grab your calculator. 3.6 squared is 12.96. 7.4 squared is 54.76. Then what we have to do is this takes an extra step from the first one. Subtract 12.96 on both sides. Those cancel, you're left with x squared equals 41.8. Now we take the square root of both sides. Hit second square root 41.8 on your calculator. You get x equals, they said round it off to nearest tenth, so we'll say x equals about 6.5. Look down at 37. It says a laptop screen, so we got some laptop. Laptop screen size are determined by the length of the diagonal. So that's crossed here. Rounded to the nearest whole number. A laptop screen has a 10-inch width and a height 8 inches. So the width here is 10 inches, the height's 8 inches. Well, hopefully this is going to be a right angle right here. So what we're doing here when we're trying to find that diagonal, which is going to give us the measurement of the laptop, is we're actually looking for the hypotenuse of this right triangle. If you remember, so again, makes stuff a little easier. So we have that. Looking for x. We're going to have 8 squared plus 10 squared equals x squared. 8 squared is 64. 10 squared is 100. That equals x squared. Got 164 equals x squared. When you grab your calculator, take the square root of both. Square root of x squared is just x. On your calculator, you hit second, square root, 164, close the parenthesis, and you get 12.8. They said it's rounded off to the nearest inch. I think that's what it said, right? Rounded to the nearest whole number. So in this case, that laptop would be a 13-inch laptop would be what it's considered. Maria walked 3 kilometers west and 4 kilometers south. Calculate how far she is from her starting point. So you got Maria. Hopefully you somewhat know your directions. North, south, east, west. She walked 3 kilometers west. And then she turned and walked 4 kilometers south. She turned, apparently she made a right angle there. So now you have this triangle. And again, you're just using Pythagorean's theorem. And again, we're looking for the hypotenuse. So it's going to be 3 squared plus 4 squared equals x squared. If you remember the Pythagorean triples that we talked about, this is one of them. We said if you have legs that are 3 and 4, then the hypotenuse is always going to be 5. You could go through and do all this math here. But if we remember that triple, we know that she is 5 kilometers That's this distance where she is now from where she started at. She's 5 kilometers from there. Continue on with this, right? It's just a video I'm putting on of your next assignment.
You start from the beginning.
Huh?
You start from the beginning.
This is your next assignment, so if you're watching, you'll see some of what we're gonna do tomorrow.
Or you just give me silence like while you're doing it. I do this later 'cause I know how to do this. I don't know how to do this.
All right, problem 40. They tell us we have this triangle, we know that this angle is 90, this angle is 60. That means this other angle's gotta be 30. So this is a 30, 60, 90 triangle that we talked about. In a 30, 60, 90 triangle, again, the very first thing you gotta do with these is go through and label them to make sure you're understanding what's going on. Side across from the 30-degree angle should always be labeled L. Side across from the 60-degree angle is L times the square root of 3. Side across from the right angle is 2 times L. When we look over here, they tell us this one this time, so we know that L equals 8. Well, if L equals 8, then all we got to do on these other two sides is plug in 8 wherever we see L.
Yeah, my dad.
Okay.
So we plug in 8 for L here. You get 2 times 8, so that means that side right there, which is Y, is 16. If we plug in L over here, you get 8, take out the L, put 8 in its place, 8 times the square root of 3, and you just leave your answer that way. So that means x equals 8 times radical 3. Don't make these harder than they are because you haven't dealt with the radicals a whole lot. That's just another way to write something, just like a decimal form or a fraction form. Radical form is just another way to write something. So 8 radical 3 is just another kind of number. Let's jump to 42. Let's see. Yeah, we'll do 42. 42. Tells us this angle is 30. This is a right angle, so that means this other angle has to be 60. So we got a 30, 60, 90 triangle. This is x, this is y. This is 14. I guess maybe over here on this one I should have put. So x equals 8 radical 3, y equals 16. Those were your 2 answers on that one. Here we go through, we do the same thing. Side across from the 30-degree angle is always going to be labeled L. Side across from the 60-degree angle is L times the square root of 3. Side across from the right angle, 2L. Every single time you have a 30, 60, 90 triangle, they all come out exactly like that. Well, this time again, they made it nice on us because they just told us that this L side was 14. So that means L has to equal 14. Well, if L equals 14, we take that and we plug it in. If we plug it in down here, then you just take out the L, stick 14 in its place, and you get Y equals 14 times the square root of 3. Up here, you take out the L, stick 14 in, so you got 2 times 14. And you just end up with x equals 2 times 14 is 28. Those are your 2 answers. if you look at problem, let's do problem 44. This is one of the harder ones I really wouldn't expect because we didn't have a whole lot of time. I wouldn't expect that all of you get it, but if you remember some of your stuff from algebra last year, you should be able to get them. Got this 60-degree angle, that's a right angle. Apparently that's a 30-degree angle, so it's a 30, 60, 90 triangle. X, Y, and this is 12. Again, we label it side across from the 30-degree angle is always L. Side across from the right angle is 2L. Side across from the 60-degree angle is L radical 3. Well, this time this is the one we know. So it makes it a little tougher. And what you have to do is you have to set up that equation there. L radical 3 equals 12. Some of you may have calculators. If you have a Casio calculator, a lot of them will do radical form, and they'll do it for you. If not, then you just got to do it out longhand like I'm getting ready to do it. Divide both sides by the square root of 3. We got to figure out what L is so that we can find these other sides. Well, these cancel, and you're left with L equals 12 over the square root of 3. Well, from algebra last year, hopefully, I'm going to rewrite this because I'm running out of space. You should have learned that you can't leave a radical in the denominator of a fraction. Now, I say that, and then on a lot of these tests that you guys are taking, they go ahead and they leave it that way. You should never ever leave a radical in the denominator. So if on the test, if they do it that way, then that's fine. Just leave it as that form right there. But what you got to do is what's called rationalizing this. And you just multiply both the top and the bottom by whatever that radical is. So I'm going to multiply the top by the square root of 3 and the bottom by the square root of 3. And what happens here is you end up with 12 times the square root of 3 on top. Get that lines there. And then on bottom, the square root of 3 times the square root of 3 is just the square root of 9. Well, the square root of 9 is 3. We'll do another one of these to make sure. And then here, what we can normally do a lot of times is these two numbers will reduce. 3 will go into 3 once, 3 will go into 12 4 times. So you end up with L equals 4 times the square root of 3. Now after we've done all that work, that's still not our answer. We come back up to the triangle and we look at X. Well, X was the same as L on that side. So X is 4 radical 3, so that's part of our answer. Now we want to find Y. Well, Y is 2 times L. So it's going to be 2 times 4 radical 3. Well, if you got 4 radical 3 twice, then that's just going to be 8 radical 3. Those are your 2 answers. Number 45, same kind of problem. So let's do it. Side across from the 30-degree angle. It's always going to be labeled L. Side across from the 60-degree angle. L times the square root of 3. Side across from the right angle, it's 2L. This time they tell us this one again, so it makes it a little tougher. So 8 has to equal L times the square root of 3. Divide both sides by the square root of 3. And if these radicals are all confusing you, a lot of times, if they want your answer in a decimal form, you can go ahead and grab your calculator right here at this point and change it into a decimal. I'm not gonna do that. So here we got L, I'm just gonna turn it around so I got more space. L equals 8 over radical 3. We don't want that radical 3 in the denominator, so you gotta multiply the top by the square root of 3, multiply the bottom by the square root of 3. You end up with 8 times the square root of 3 on top. You can't multiply a regular number inside the radical. So when you multiply 8 times the square root of 3, it just ends up being 8 radical 3. Down here on the bottom though, they're both radicals. So it ends up being the square root of 9, which the square root of 9 is 3. That won't reduce this time, so that's what our L equals. Now we go plug that back in up here. Well, that means X is just going to equal that. So 8 times the square root of 3 over 3. And over here we want to double it, so Y is going to equal 16 times the square root of 3 over 3. Those would be our two answers. Okay. Look at number 48. Something I should have said in class, which I think I might have forgotten in some of the classes. If you have this triangle, this is a 60-degree angle. The original triangle would be an equilateral triangle. Because if that angle's 60, all the original angles are going to be 60. That's 90. And this happens every time you have an equilateral triangle. If I just look at one of these triangles, so if I split off the triangle on the left, I know this is a 60-degree angle, that's a 90-degree angle, and this angle up here has got to be a 30-degree angle. This is our Y. This is 16. Let's see, did I forget anything there? Yeah, X is right here. Side across from the 30-degree angle should be L. Side across from the 60-degree angle is L radical 3. Side across from the right angle is 2L. Well, this time they told us that side. So we know that 2L should equal the number they told us, which was 16. So L has to equal 8. This one's not too difficult. The one that's difficult is the one where they give you the side across from the 60-degree angle. That's what makes it difficult, when you got to deal with the radical right off the bat. So here we go back and all we do is plug in 8 wherever we see L. So over here for X, it's just L, so we know X has to equal 8. Over here on Y, we're going to plug 8 in right there. So Y is just going to equal 8 times the square root of 3. All right, if you jump down a couple of problems, let's jump down to problem 49. These are the 45, 45, 90 triangles instead of the 30, 60, 90 triangles. They tell us this information. Again, first thing you should do, label all these. The side across from the 45-degree angle should be labeled L. Side across from the other 45-degree angle should be labeled L. Side across from the right angle is L times the square root of 2 this time instead of 3. Well, we look right here, that's the side they tell us, so we know that L has to equal 8. They didn't ask us this, but that means this side over here has to be 8. They just ask us to find X in this case. Well, X here, we put 8 in right there in place of L. That means X is going to equal 8 times the square root of 2. That's our answer. 8 times the square root of 2. Problem 50, they give us another 45, 45, 90 triangle. Mine doesn't look quite like theirs, but close enough. It's X, that's Y, this is 14. Again, if this is 45, that's 90. We know this other one has to be 45. Side across from the 45-degree angle is always going to be labeled L. Side across from this 45-degree angle is going to be labeled L. Side across from the right angle is going to be labeled L times the square root of 2. Understand any of that?
I didn't even look at the board on here.
The 45, 45, 90 one's a little easier than the 30, 60, 90. So we have all that. We look right here. That tells us L has to equal 14. Well, then we know that over here, this side has to be 14, so X equals 14. That's one of our answers. And over here, we know that if we stick 14 in place of L right there, then Y is going to be 14 times the square root of 2. .51, then I'm going to jump on to the next one. They give us, if you got a square and you draw a diagonal in the square, that's your diagonal. Each side of the square is 18 units long. Well, this is going to be a 45, 45, 90 triangle. So if I just split off one of those triangles, this is 18, that's a right angle, that's 45, that's 45. Sides across from the 45-degree angle should be labeled L. Side across from the right angle is L times the square root of 2. Well, we know L equals 18, so this diagonal length right here, that's X that we're looking for, has to be 18 times the square root of 2. Most of the rest of the problems from 60 all the way to the end of the packet are sort of kind of the same problems where you're using the trig ratios. So I'm going to do a couple of those just to set them up for you. So we're looking for a side of the triangle, but we know an angle and a side, so we have to use our trig ratios. You can't use Pythagorean theorem, you can't use 30, 60, 90, you can't use the 45, 45, 90 because it doesn't fit any of that. So what we have to do here is we're going to label this triangle according to the trig ratios. We know that we want to deal with that 32-degree angle because that's the angle they gave us, so it's one we might as well deal with. And you label it this way. Side that's directly across from that is called the opposite leg. And I usually won't write out opposite leg, but the side that's across from the right angle is always called the hypotenuse. So we label it. then the side that's hooked to the angle that we're dealing with is called the adjacent leg. Now, anytime you're setting up one of these trig equations, when you're using one of the trig ratios in an equation, what you have to do is make a decision on what parts you care about. Well, here we know the hypotenuse and we're looking for the opposite leg, so we probably care about those two. The adjacent leg, we don't have to find it, and they didn't tell us what it was, so we probably don't care about it. So we're dealing with opposite leg and hypotenuse, and that's where we go back to our total. And we got to decide which trig ratio are we using, sine, cosine, or tangent. Well, we care about the opposite leg and the hypotenuse, so we look through here, opposite and hypotenuse, so that's this one. So when we set up our equation, the S again stands for sine, so we do the sine, and it always goes this way, sine of your angle. So if you wanted to set it up, it's always the trig ratio, then the angle, equals, and then some ratio, whatever it is, opposite over hypotenuse, so it's, this time it's, our opposite leg is x, I started to say 60, it's x over the hypotenuse, which is 9. Now you have to grab your calculator. What you do on your calculator, start to solve this, and if you can get the equation set up, like we just did right there, that's the hardest part, because then everything else the calculator will do for you. First thing you do is you want to get rid of this word sine. So on your calculator, you hit sine 32, and it tells you 0.5299. Now once you have that, that sort of looks like a proportion, except we have a ratio on the right, but we don't have a ratio on the left. Well, the easiest thing to do, put a 1 underneath that and make it a proportion. Now it's going to solve just like every other proportion that we've been doing for the last week or two. We cross multiply, 1 times x is 1x. Multiply this way, 0.5299 times 9 gives us about 4.769. Divide by 1, which isn't going to change anything. I need to go back and read the directions. It said round your answer to nearest hundredth. So that means we want to go out 2 decimal places. So here x is, we're going to go out to this second place right here. X is 4.77. And I didn't even look at our units. Did they give us, they didn't give us any units on that one. So x is 4.77. All right, we'll jump down to, let's say, 64. I don't know, just picking one at random here. The right angle there, this angle is 83 degrees. This is x, this is 9. Apparently we want to deal with this angle. That's the opposite side. Hypotenuse. This over here is the one that's hooked to the 83, so that's the adjacent. We're trying to find the hypotenuse. We know the adjacent, so this time we really don't care about the opposite leg. So we go back, so, TOA, and we want the one that deals with adjacent and hypotenuse. It'll be right there, so that's the cosine. So when we set up our equation, it's going to be the cosine of our angle equals adjacent over hypotenuse, 9 over x grab our calculator, hit cosine 83. I'm going to write it over here so that I don't have to bend down. And we get 0.1219, I'll round that up, go out about 4 places. 9 over x. Now again, it sort of looks like a proportion. First thing I'm going to do, put a 1 underneath there, make it exactly like a proportion. Cross multiply, get 0.1219x equals 1 times 9 equals 9. This one's got an extra step on it because of where the variable was, because now you have to, the other one had a 1, so we didn't really need to divide by 1. This one we have to divide by that. These cancel. Something you got to remember when you're dividing with these decimals, if you're dividing by something that's less than 1, your number should get bigger. So this 9 is going to get bigger. Usually when you're dividing, your number gets smaller. When you divide here, it's going to get bigger. I came up with something like x is about, they said round it up to the nearest hundredth. So x is about 73.83.